Hello and welcome to Thursday's edition of Cracking the Cryptic, and on screen we've got perhaps the most popular standard puzzle that we've very rarely covered on Cracking the Cryptic. We haven't, I think it's probably 2 or 3 years since a Kakuro puzzle has featured on the channel, and we're going to put that right today. What we're going to do, you may have heard me in recent videos plug Prasanna Seshadri's Parallel Universe 4 competition, which finished about an hour ago, I believe, on Logic Masters India. And Prasanna's been kind enough to share with me the 2 Kakuro puzzles from that competition. So these are incredibly current. We've got one standard and one variation. And apparently the variation was the most popular puzzle on the entire test. So we should be in for an absolute treat today. And I am really looking forward to trying a puzzle type that I've not done for ages. Now, I know a number of you will be familiar with Kakuro, but I just want to say a quick word about it. If you've ever tried these in your newspaper and thought these are a bit dull, you're quite right. If you do newspaper Kakuro, they are incredibly dull. They are awful puzzles all over the world. And what you really have to do to appreciate the beauty of this puzzle is to seek out handcrafted variations. It's a little bit like Sudoku in that way, that there are some beautiful Kakuro puzzles, notably by Nickley, of course, the Japanese company. And I presume Nickley invented Kakuro back in the day. But you know, you're going to have to seek them out. There's lots of places on the internet you will find handcrafted puzzles, and they are well worth the effort of the hunt. Now, before we get into this, 2 things I want to talk about today. Firstly, if you are a patron of the channel, then over on Patreon at the moment we've got our solution video for the Tour de France bonus monthly puzzles that we released at the start of September, so do check out the video. And secondly, yesterday's video, which was on Fistimafel's Cloverleaf Sudoku. Well, predictably enough, there were other ways to solve it, and I thought I would just quickly spend 1 minute showing you the method I think Fistimafel intended, because it's rather clever, and it would have saved me a lot of heartache at the start of the video. I'm actually quite proud, having seen the way I think you were meant to solve it, that I managed to solve it at all. But let me show you what I think Fistimafel intended. So if we have a look, this is the setup with the clover leaves highlighted. Now what we needed to do, or what I needed to do, was to have if we think about the top 4 rows of the grid, we know that these 4 rows will add up to 180, because each row individually will add up to 45, because it contains the numbers 1 to 9. So 4 lots of 45 is 180. Now if we look carefully, we can actually work out the value of this 4x4 in the top left hand corner, and we can do that because we know that, again, a single box will add up to 45, but we've got these cages around the box that add up to 30. So in fact those orange squares there add up to exactly 75. So I want us to remember that. Maybe I'll highlight those actually like that. There we go. Now, so here we've got 75. Here we've got an unknown amount in these squares here, and here in the top right hand corner we've got a 4x4 purple region. Now let's repeat this exercise on columns 6 through 9 and have a think about this. And you may wonder, why on earth are you doing this? Well, I will show you. And you know, I hope you'll forgive me at the end of this that I didn't spot this. I probably should have spotted it, but it's never easy when you're doing puzzles with this much complexity to know exactly where to start. And apparently Fistimafel on Logic Masters Germany did give some hints that indicated that this was the way to start. And obviously we don't look at those on Cracking the Cryptic, so we just have to find our own way. Now, so let's repeat the trick. What is the sum of these orange squares? Well, again, it's going to be 45 plus those perimeter cage cells, which add up to 50 in this case. So this time we've got these orange squares adding up to 95. Now this is where the trick gets interesting. So we can express the top sort of, I'm going to call the purple region, I'm going to say the sum of the purple region is equal to A. Okay, so we can describe the top of the grid as the blue cells plus 75 plus A equal 180. Now let's do the same on the columns. I'm going to call, so this purple region is still A. We then know we've got 95 plus the red squares cells plus A equals 180. So I can just make these two equations equal to one another. They both equal 180. And you can see that what's going to happen here is this region is common to both sides of the equation, so it just cancels out. And we end up with 75 plus the blue squares is equal to was it 95? Yeah, 95 plus the red squares. In other words, the blue squares minus the red squares have got to equal 20. Now, why is this interesting? Well, what's the maximum difference we could get these digits to have? I'd have to put the absolute maximum I could into those squares. Well, because they're all in the same column, they've all got to be different numbers, so I could make them 6, 7, 8 and 9. The absolute minimum I could make these squares 1, 2, 3 and 4. What's the difference between 30 and 10? It's 20. It's the number we were after. So this square here then becomes a naked single. It's the 5 that it took me about 30 minutes to find in yesterday's video. So that was the quick way of doing it if you spotted it. Forgive me for not spotting it. I'm a little bit sorry, but that was pretty difficult, so I will forgive myself on this one occasion and not wear the hair shirt. Let's get back to Kakuro and Prasanna's puzzle. Let me read you the basic rules of Kakuro. I'm sure you're familiar with them, but let me read them. We've got to enter a single digit from 1 to 9 into each white cell so that the sum of the digits in each across entry equals the value given to the left of the entry or above the entry. And the sum of the digits in each down entry equals the value given above the entry. No digit may be repeated within a single entry. So it's a bit like Sudoku in that sense. We can't repeat a digit in an answer, and we have to use the digits 1 to 9. And it's a bit like killer Sudoku in the sense that you have these, the equivalent of cage totals. Now, do have a go. The way to play this one is to click the link under the video. I'll run through the rules for the second puzzle when we get to it. And with that, let's get cracking. Now, the way to start Kakuro is normally to look for, certainly for handcrafted puzzles, it's to look for big differences between entries in rows and entries in columns. So, for example, down there we have a 10 clue, and across here we have a 21 clue. So if you get quick at these, you can instantly spot that this has to be a 4, because if we know that the 10 clue must be 1, 2, 3 and 4, because we've got to use 4 different numbers, and the only way of making 10 with 4 different numbers is 1, 2, 3 and 4. And once we know that, we can't put less than 4 in here, because we can't make those two squares higher than 17, even with 8 and 9. Which would be the maximum option. So this has to be 4, these two have to be 8 and 9. 1, 2, 3. Look, we've got a 27 clue here. So what's the option for this square here? That's got to be a 3, otherwise those squares cannot add up to enough. The maximum value for 3 squares when you can't repeat a digit is 24. We know that from Killer Sudoku. So we get this arrangement, this one now. And you can see how when you get a good, well-designed Kakuro, the logic flows. It's fairly linear. So this clue here, this is going to have to be a 7, because we know the maximum for the minimum for these squares is 10. So if this is any higher, we can't keep these down enough. So we get the 7 there. These the 4 must go here. We know these are 1, 2, 3 and 4. We've just looked at that for a 10 clue. These are effectively a 10 clue now. The 13 needs at least a 4, so that fixes all of this. And we get on a little run. And if you ever see, we did do a video of Jason Zufranieri solving a big Niccoli Kakuro puzzle, and if you've not seen it, I will try and remember to put a card on the screen now, because it is fairly frightening in terms, Jason is the fastest Kakuro solver in the world. I think most people would agree with that. Maybe Hideaki Joe would have something to say about it, but it is frightening how quick he is at it. To 35 in 5 cells, well, that's got to be 5, 6, 7, 8, 9. We've got the 8 and the 9, so these have to be 5, 6 and We've got to be very careful with this 19 total now, because even if I pick maximums for those two squares, this square would have to be a 9. So in fact, I am going to have to pick maximums in order to make that work. So we get a few more digits in the grid. And we get to look again there. 30 is juxtaposing with 16. So this square has to be a 6. A 16 clue in 5 cells cannot contain a digit higher than a 6. A 30 clue in 4 cells cannot contain a clue lower than a 6. That square's got to be a 3 or a 4, therefore. Ah, this square as well, look. This square's got to be the 7. Because if we put 8 in this square, we'd have to put double 1 in those squares. That would breach the rules. So we get that. We get to put 8 and 9 in here, 8 and 9 in here. Now we get stuck. Oh no, we don't. 8 and 22. Again, just looking for big differences. What's the minimum value you can put in a 22 clue? 5. What's the maximum value you can put in an 8 clue? 5. So we must do that. So 3, 3. This has got to be 1, 2. This can't be 1 because we can't make those 3 add up to 25. So that's 2. That's 1. These are 7, 8, and 9 in some order. This is 8 and 9. Oh, look. Now, we've got a little triple there straight away. This square can't be 8 or 9, otherwise it will clash with these two. So that's got to be the 7. And can we go further? We probably can. We've got quite a lot of digits, actually. Is this a 9-cell line? 1, 2, 3. Yes, it is. And if you actually look there, we've got 7, 8, 9, and 1, 2. So we're looking for 3, 4, 5, and 6. It's not that helpful, actually. These 3 squares have either got to add up to 7 or 6, because this is 8 or 9. So we know that the only options for these squares are either 1, 2, 4 or 1, 2, 3. Okay, it looks like we're getting stuck there. Ah, look, again, picking off the big juxtaposition, this square. The minimum I can make 3 cells add up to is 6. So the maximum value for this square is 7. But 23 in 3 cells, we know that that's 6, 8 or 9. Well, this can't therefore be 8 or 9, it has to be 6. These have to be 1, 2 and 4. 7 and 12 here, that's another classic Kakuro entry. That square's going to have to be the 4 because it can't be a 1 or a 2. This square's got to be an 8. This square's a 6 or a 7 therefore. And 14, this square's 4 or 3. Doosh, 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 doosh. Okay, now let's have a look down there maybe. Yeah, this square is the restricted one, isn't it? Because this can't be 7, 8 and 9. Well, we know it's got to be at least 6, because otherwise we can't get this to be high enough, given this square is a 3 or a 4. So this is 6, which means this is 15, which means this is 12. We can't repeat the 9, so this must be 4 and 8. That gives us a 9 over here, and you get these lovely runs. It's so satisfying if you get on a run in Kakuro and you can put a flurry of digits in. You feel so clever. You can do all that, we can do that. These squares here have now got to add up to 7, so we can remove the 3 as an option. And this line is getting incredibly constrained. We need 3 and 4 at the end. Where does the 6 go? In column 1, look. We know that 16 has got to have a 6 in it, and there's a 12 clue. So we can't put it here because we'd have to repeat the 6. So we go 6, 2, 2, 1, 4, 1, 2, 4, 3, 3, 9, and that's the top bit done. So now we need, that's not 4, look, because of the 4 here. 1, 2, 3, 1, 2, 3. And, okay, now we get stuck again. Let's try and finish this off. Ah, here's a good one. The 22 clue we know must have a 9 in it. We know that from Killer Sudoku. Where does the 9 go? Well, it can't go here. There's already a 9 in the row. It can't go there. This is an 8 clue, so it must go at the bottom. 9, 2. This has therefore got to be 5, 6 or 7. This has got to be 1, 2 or 3. and it can't be 2, so that can't be 6. We don't know what this total is. But if this is 5, this would have to be 8, which would clash, so it's not. This is 7, this is 6, this is 1. Okay, hang on a second. He says somewhat arrogantly, assuming he'll be able to figure out this mess in the middle here, but actually that's quite tricky to sort out. Really is quite tricky to sort out. 1, 2, 3, 4, 5. Good grief. Okay, well, this is very unusual for a Kakuro. You don't often see a trick in a Kakuro, but this has a trick in it. This has a trick in it. Look at that. This is really clever from Prasanna, actually. In a competition, I guess you might not see this. You might just bifurcate to try and get a solution, although I'm not actually sure that would work. So the trick is the fact that we can, in fact, we do know the value of all these cells, in the sense we know the sum of all of these cells. And we know the sum because we've got 16 in this row. This is a 9-cell row, so this adds to 45. And look, every other row sum is given. Now, if we look at the columns, this one is a mystery. We don't know what this column adds up to, but every other column in the bottom part of the grid is determinable, either because we have a clue or we've already got the digits. So we actually are going to be able to isolate the value of this square, and that's going to tell us it's going to hopefully disambiguate this gibberish in the middle. So let's see if we can do the maths. So we've got 61 there, plus another 24, isn't it? So that's 85. If we do all of those, 96, 99, 119, 131. So 131, let's remember that. Now here we've got 22, 25, 40, 67, 80, 101, 113, 120, is that right? 120, 138, which is higher than the number I just got. It should be lower than it. I've done something wrong there. What did I do wrong? 22, 25, 40, 57. I said 67, didn't I? So it's 10 lower. 10 lower than the number I first said, 138, 128. That would make that square a 3. That does look correct. Okay. It pays to be able to do simple arithmetic. If this is a 3, which I think it is, 131 minus 128 is 3. That would give us a 4 here, which makes this square equal 6. This gives us a 2 and a 1. The 1-4 pair tell us that this is a 2. That gives us the 1 here. This is so clever. Now we're missing, look, 5s and 7s into those squares. And that's got to be a 4, which is in an 8 cage. So now we know that that is a 1-3 version of the 8. There's no 6 in either of those squares. And somehow this is resolvable. How is it resolvable? So let's look at this one. So if we pick minimum values for all of these cells, we get 7, 8, 16. Perfect. So if this is 16, if we pick minimums, I can't pick a 7 here or a 3 here because I'll break the total. So this has to be 5, this has to be 1. So this is 3, this is 7. 10 here, so these have to add up. 3 in fact, that's going to fix it, isn't it? 3, 2, and you can see now we've got 9 there, so we should have 8 and 9, 12, and 9 is 21. That is a brilliant puzzle, and that's why handcrafted puzzles are better. So now let's have a look at the second one. It's this one. Now this has some extra rules. It's identical to the first one, okay, but you can see there are some shaded cells. Now let me read you the rules about the shaded cells. Some cells are shaded, and the digits in these shaded cells also act as Kakuro clues for subsequent white cells, i.e. until the next grey cell, black cell or grid boundary. It is up to the solver to determine if the shaded cell digit is an across or a down clue, and it could be both. So just picking this square for a moment, that's saying, okay, this square is definitely summing those two because it hits a grey square immediately below it. Let's look at this one. This is a better example. So this grey square here is either summing those three cells or these two cells. We don't know which one, but it's basically acting as an extra Kakuro clue. I say extra, I mean there's very few clues around the edge here on the left hand side. So Prasanna has been very modest in how many clues he's decided to give us here. So this clue, this grey square, is either summing those three or those two, etc. So that sounds brilliant. Again, click the link under the video to play. Let's get cracking. And how are we going to do this one? 16 in two cells has to be 7 or 9. There's another 7 or a 9 there. So what I'm doing here is I'm just scanning to find totals that I know are restricted. So 23 in 3 squares has got to be 6, 8 and 9. Okay, that's not actually going to take me far enough into the puzzle, I don't think. So we're probably going to have to look at one of these grey cells to find out. So if this is 7 or 9, those 3 squares, well, that's not putting a great restriction on these. But it would be nice if we knew it was 7. It would have to be 1, 2 and 4. This 12 is an interesting clue, because if it was a horizontal sum, the minimum I could make those 3 squares add up to would be 6. If I put 1, 2 and 3 in them, that would make this a 6. But this could be summing those 2 cells. There's another. Oh, hang on, there's another 12 clue here. Okay, this is very interesting. So this square is quite, I think, the place we should start the puzzle, because is this operating as a sum of those 3 cells, or is it saying it's the sum of this cell? Well, it's not going to be the sum of this cell, because if I put, for example, 3 in there, if it's summing this cell, that would also have to be a 3, and that breaks the rules of Kakuro. So this cell is summing these 3 cells, and therefore these have to be 1, 2 and 3, and this has to be 6. That is simply the only way you can make this clue work. Now that means this clue is definitely, well, it can't be a 6. So this square is summing those 2 cells. So this square must at least be equal to 3, because the minimum I could make these 2 squares would be 1 and 2. And you can't put a digit higher than a 7 in a 12 clue. So this is 3, 4 or 5. These 2 squares are 1, 2, 3 or 4. This can't be a 3 because it's in a 6 clue in 2 cells. This column adds to 36, look, and there are 8 cells in it. So there is no 9 in this column. How do we know that? We know all the digits add up to 45. So if we're missing exactly 1 digit, it must be the 9. There's another 12 clue. And this again can't be taking the sum here. So this is also 6, 1, 2, 3. So it feels, the thing about brilliant constructors, top tier constructors like Prasanna, is that they will often give puzzles a theme. You know, that there will be an idea that they try and introduce in the puzzle, and these 6s and, well, these 12 clues feel to me like this is, you know, this is the thing Prasanna wants us to think about at the start of this puzzle. So I'm going to think about it. Now, this is the other thing. Imagine if you're doing this under competition conditions, so you're desperately trying to solve this as quickly as you can. It is a different type of skill to me sitting here sort of gibbering away. Hang on, what do we do here? Ah, I've got something. That cell is a grey cell. So that is acting... Oh, yeah, this cell is interesting. That's acting as the sum of those three cells. Well, the minimum... in fact, I can't. I can't make these cells 1, 2, and 3, because if I do, that cell has no value. So, oh, this is brilliant. This has to be a 7. Now, why does this have to be a 7? It's because it's in a 17 clue. So a 17 clue in 5 cells cannot contain a digit higher than a 7. But I can't put a digit lower than a 7 in here, because that will break this cell here. So this is 1, 2, and 4 exactly, and that's going to give me a 3 here, which finishes off those. This is all now 1, 2, 3, and 4 in some order. That the 11 clue in 2 cells can't have a 1 in it, so this square is 7, 8, or 9. No clue though for that clue, so that's no use. This clue can't be a 3 because it's part of a 6 clue in 2 cells, so we get 5, 2, or 4 in there. Ah, now, hang on. There's no 9 in this column, so we've still got to put 5, 6, and 8 into this column. So I'm thinking about this cell. This can't be an 8 because it's a 4-cell 12 total. And this is grey. So this can't be a 5 or a 6. This has to be 8. And this is 3. This is brilliant. This is brilliant. So that's a 5. That's a 6. That means these 3 squares have got to be 1, 2, and 3 to make 12. And that square can't be a 4 or a 5. So that's a 3. That's a 2. That's a 1. That's a 4. What a brilliant... It's just a beautiful idea. We've got a 2, 3 pair here now. So this must be a 1, which means that's a 2 because those two are adding to 3. This is a 26 total. And we've got 12 so far. So these two add up to 14 without using 6. So these are 5 and 9. Don't have a clue total for that one. That's not helpful. Ah, okay, we've got another grey cell to help us out there though. This square is very important because obviously the sum for this square is not the cell below it, or it would be the same digit. So it's the summing these 3 cells. So this can't be a 7 because even if I make that a 5, I'd have to put 2 1s into those squares. So this is 9, this is 7, this is 5. These two have to add to 4, so they're 1 and 3, 2, 3, 8. This square now can't. So this square now is interesting. That's not summing those two because they sum to 10. So it's summing these two. Not sure if that's important or not. Let's have a look back at the top though. We've got... Oh, this grey cell is important now. There's a 7 here. So this can't be summing those 3 squares because the minimum I could make those squares would be 10. Even if I put 1 and 2 in, I still get to 10. So this is summing these 2 squares, so this can't be a 9. Otherwise, again, we're going to get to that 10 total. So this square, well, well, we can't put a 2 in here. So this has to be 1. Again, if I put 3, I'll get to 10. This is 8. So now this square, look. Oh, this is forced. This is forced. This cell, which is grey, has to sum those 2 cells. What's the minimum I can put in those 2 cells? Well, 1, 5, and 3 have gone. So it's got to be 2, 4, which means this square is a 6. We can't make this lower than that because I can't make those 2 lower than that. So this is 6, this is 2, this is 4. If this is 2, that would put a 7 here, and that would clash. So this is not 2, it's 4. 2 in the third. You can see it's what I love about good puzzles like this is there is a path. We have found the path. We had the idea on the 12s. That got us into play with this 7. That helped us out, sort of gradually wend our way, got us into the 26 clue, which has allowed us to come across here and now down this side. And it's all flowing. Now this 32 clue, once there's a 2 in it, these 4 squares have to be 6, 7, and 8, 6, 7, 8, and 9 to add to 30. So that's got to be 6. These have got to be 7 and 8. There's an 8 there. Of course there's an 8 there. That's what Prasanna intended. This 8 adds those... Ooh. Okay, so the thing I notice the moment I see these add up to 8, and I notice these 2 squares add up to 8 as well, is that those 2 squares have to contain the same digit. Because whatever I put in there, obviously, you know, this sums to 8, this sums to 8. Those 2 must be the same. You can see the top, from the top here, this has got to be 3. It can never be 4, or you'd repeat 4 in the 8 clue. So it's got to be 3, 5, or 6, which means this has got to be 2, 3, or 5. Oh dear. Now... Oh, I see. Again, we're being forced to use our brains here. Look at this clue. Look at the geometry of this clue. It's very clever. We've got a grey cell here, which we know is not the sum of those 2. So this grey cell is summing these 2 cells. We've got a grey cell here, which can't be summing this cell, or it will be the same digit. So this cell is summing these 2 cells. So we can actually express this 34 clue algebraically. It's equal to x, whatever we put in there, plus another x in this domino. So it's equal to 2x plus y, and that will also equal y, so 2y. So this clue is 2x plus 2y, which means that x plus y has got to equal 17 just by algebra. Because 2x plus 2y equals 34. If we divide through by 2, we get x plus y equals 17. How do we make x and y equal 17, given they have to be different digits because they're going in these 2 squares? They've got to be 8 and 9. This can't be an 8. This is a 9. This is an 8. And that is absolutely beautiful. Again, 3, 6, 4. Just looking at the options for these 2 cells now. Can we do anything across there? No, that's got to be 1, 2, 3, or 4 in the 5 clue. Okay, so I've done okay here, but I'm still struggling a bit to understand how to disambiguate this bit of it. It would very much help if I could eliminate the options here. The 8 clue, there's no 8 here, therefore. These 2 squares have got to add up to 8, but we don't have really any restriction on those yet. Oh, that's got to be a 9. Look, I could have done that a while ago. Maybe this 9 helps. It doesn't help because we don't know what goes in there. I must be looking for another grey cell, I think. That's going to be the key. This grey cell, maybe? Oh, there are 2 more grey cells I've just spotted that are interesting. This one is interesting because whether this is 4 or 5, these 2 squares have to be very low numbers. So if this was 5, this could be 4. So this has to be 1, 2, 3, or 4. So you can see we've almost got a good restriction coming along here, but not quite. But the other digit I thought was interesting suddenly is this one. This is grey, and there's a 5 in its sum. So these 3 cells are being summed and have to equal whatever we put in here. That's it. We could use uniqueness here. I'm not going to do it, but let me just show you. If this square was an 8, that would put 1s and 2s into those squares. Now look, there is no way to tell which way round these go. But there's just simply, you know, it doesn't affect anything. It doesn't affect the row totals or the column totals, and it could just as easily be like that. So if you were speed solving, again, what you could do here is you could, what I think we'll find, and I won't assume it, is that this square here cannot be an 8. I think it's going to have to be a 9. But anyway, we, as I say, we won't assume that. So the options here, given this has to be, there's a 5 here, the minimum I could put in here would be 1 and 2. The maximum I could put in there would be 1 and 3. This square is an 8 or a 9. And you can see, beautiful. Look down here. We've now got a 1, 2, 3 triple. Therefore, this square is a 4. Therefore, this is a 5. This is a 1. This is a 1. Remove 1s from all of these cells. Can we go further? Please? Yeah, we can, of course. Look, this square's got to be a 9 because this adds up to 19. The 1, 4 pair here tell us that, oh, whoopsie, tell us this isn't 1 or 4, this isn't 1 or 4. The 4 here tells us this isn't a 4, so this isn't a 5. These have to add to 9, remember. So these are now 3 and... Oh, this is gorgeous. Look, once you get this being 3 and 6, what are the options to make this domino add up to 8? We can't use 3, 5 or 2, 6 anymore. This is 1, 7. Oh, does that not help? No, I don't think that does help very much, actually. If this is 3 or 6, the options for this square have changed, haven't they? This can no longer be a 3. This can no longer be a 5. I think I'm missing something with my scanning, but I can't quite see how to resolve this. I'm sure we're not meant to use uniqueness, so there must be another way. Why have I got 2, 4 here? Here you go. Once this adds up to 12, we can, once we get the 1 here, in fact, we now know this has to be the 2 because it can't be a 4. So that presumably helps us. Well, it does a little bit. No, I think we still need to do something down here. Oh, yeah, it's this cell. This is the key. This is grey. So it's the sum of 3 digits, but this has to be a pretty big digit. So you can see this can't possibly be anything other than 6. So 6, 1, because that can't be 7. This must be 2, this must be 9. And that, I think, is going to crack the puzzle. Once this is 8, this is 9, as we thought it would be, because we knew this wouldn't be a 1, 2 pair. So this is 3, 1, 2, 1. This square's a 7 now. Oh, this is an interesting square. 1, 2, 3. This is a 7-cell clue adding to 35. So it's missing 2 digits which sum to 10. Well, you can see the 7, 8 and 9 already in the answer. So the digits that only add up to 10 that must be missing must be 4 and 6, which means this square must be a 2. That's very clever. This 8 clue is now fixed. Look, that gives us a 6 there. We don't know the total for here. But this square is, this square is summing these 2 squares. So what are the options? 9. Oh, this, yeah, look. This square is determined. It can't be 9, it can't be 9, 8, 7 or 6. So the maximum it can be is 5. If it's lower than 5, it would need a 1 in its sum, and it can't have one. So this is 5. Meaning these 2 squares are 2 and 3, but this 5 here is going to resolve everything, I think. 2, 6, 6, 3, 2, 3, 3, 2. The check function won't work because it's not Sudoku, but that is just a beautiful puzzle. Again, I loved that today. I hope you guys got something out of it too. Let us know in the comments. If you really enjoy Kakuro, we can certainly find lots more handcrafted versions for you. And we'll be back later, of course, with another edition of Cracking the Cryptic.